Our lesson today is on expansion and contraction. So our question for this lesson is, why do materials expand and contract? First of all, we need to complete a knowledge check, so make sure that you pause the video and give yourself enough time to answer all 8 questions before the answers appear. Here are the answers to the questions. So for the first question, the 2 units of density are grams per centimetres cubed or kilograms per metres cubed, and you can put either one of those units. The equation for density is density equals mass divided by volume, or D equals M divided by V. The equation for weight is weight equals mass times gravitational field strength. And the equation for pressure is pressure equals force divided by area. The equation for work is work done equals force times distance. An object floats because it has a lower density than the liquid it floats on, and most commonly that liquid is water, but it may be a different liquid. The answers in boxes 7 and 8 are many examples of vectors and scalars. As long as you have 2 correct examples, then you can give yourself the marks for that answer. Make sure that you mark your work and do any corrections in a different coloured pen. First of all, we are going to talk about particle theory. So according to kinetic theory, solids, liquids and gases are made up of particles which are constantly in motion, and in solids they will be just vibrating. In liquids and gases they will be not only vibrating, but also the particles will be moving around each other. If a substance is heated, the particles will vibrate more, they will move around more or vibrate more. This greater vibration means that the particles will move faster, and this means that the particles take up more space. Because they are moving around more, the particles take up more space, so then the material, the substance, gets larger. We call this expansion. To support this idea, watch the YouTube clip below. So either copy the link or search the title of the YouTube video, and make sure that you write notes on the expansion for each state of matter. So solids, liquids and gases, you need to write notes for each one. To summarise the idea of expansion and contraction then, substances expand when they get warmer, so when they are heated, and expansion means that the substance increases in size. Substances then contract when they get cooler, and this means that they decrease in size. When substances expand or contract, it's important to know that the particles themselves stay the same size. It is just the space between the particles that change. So you can see in the diagram on the right hand side, a cold object versus a hot object. The particles vibrate more, so the space between the particles is taken up more, which means that the object expands. So the particles vibrate or move more when a substance is hotter. So there is more space between the particles when a substance expands, and that means that then the substance increases in size. Whereas on the left of that diagram, the particles vibrate or move less when a substance is cooler, so there is then less space between the particles if a substance contracts. So you can see that the object is much smaller because The space between the particles is much less. Now we are going to look at the effects of expansion and contraction. So when some substances expand or contract, these can produce very large forces. For example, in hot weather, steel bridges expand, as do electric wires. A big example of this is the Eiffel Tower, which can be up to 17 centimetres taller in summer than winter because it is hotter, and therefore the particles in the Eiffel Tower material are vibrating, moving much more in summer than winter. This then takes up more space because the particles are moving more. Actions can be taken then as a precaution in terms of a substance expanding or contraction. So for example, on the end of one end of a bridge, it's often supported by rollers to allow for the movement caused by expansion. Another example is electric wires are slack. This means that they are not tight, they have a bit of kind of flexibility to them to allow for expansion and contraction. Another example that isn't written down on here is that the shelves in an oven are only loosely fitted, and that's because the metal that makes up the shelves will expand when it is heated and then contract when the oven cools down. So the shelves are not tightly fitted in place because people know that when the oven gets hot, the metal will expand, and then when the oven cools, the metal will contract. So they are loosely fitted for this reason. To support this idea, there is a YouTube video that you can watch, so either copy the link below or search the title of the video. Make sure that you pause this video so that you don't miss any of the content. Now we will talk about bimetallic strips. So a bimetallic strip consists of two different materials, often metals or alloys, that expand at different rates and they are bonded together. So you can see in the picture on the right hand side at the top, this is what a bimetallic strip looks like when it is not heated or cooled. So you can see that one material is on the top and the other material is on the bottom, and they are bonded together. Now, the most common materials that are used for this are steel and copper, but in some cases it can be made out of steel and brass, as in the picture and the examples that I'm going to talk about, or it could be used with iron and brass. And the video at the bottom of the page, the bimetallic strip that she is looking at in that video is made out of iron and brass. Now, when the bimetallic strip is heated, one of the materials expands more than the other material that is included in the strip. So in this example, the brass expands more than the steel when it is heated. And this then means that the strip curves with the brass on the outside. The force of the brass expanding makes the bimetallic strip curve round. Similarly, if the strip cools, then it also curves. The force of the contraction causes it to curve as well, but this time it is the other way around. So it curves with the steel on the outside instead of the brass on the outside. You can see what these effects then look like in the picture on the right. There are lots of uses of bimetallic strips. One of these uses is as a switch in a thermostat. A thermostat is to do with regulating temperature, so bimetallic strips can be used in thermostats. Make sure that you check out the video underneath, either copy the link or search in Google bimetallic strip BBC bite size, and you should then be able to find the video. Make sure that you pause this video when you are watching that video so that you don't miss any content. Last of all then, we need to do a knowledge check. So make sure that you pause the video to give yourself enough time to answer all 9 questions. Here are the answers. So the movement of particles in a solid, the particles in a solid vibrate in a fixed position. They are also in a regular arrangement, but because it's asking for the movement of the particles, we say that the particles vibrate and they are in a fixed position. So they don't actually move around, they are fixed in place, but they vibrate. The second question then, when a solid is heated, what happens to the particles? The particles vibrate more, and this means then that they take up more space. So for question 3, what happens to the speed of particles when a liquid is heated? The particles move faster as they have more kinetic energy. Remember that this then means that the particles take up more space, so the liquid expands. Number 4, when a metal is cooled, what happens? The answer is that it contracts as the particles vibrate less as it cools. So they have less kinetic energy, so the particles vibrate less. There's less space then between the particles, and that means then that the metal becomes smaller. Okay, it contracts. That means that it gets smaller. This then leads into question 5 and 6. So when an object is heated, it expands, it gets bigger because the particles vibrate and move around more. This means that then the particles take up more space, so the object gets bigger. When an object cools, it gets smaller, it contracts because the particles have less kinetic energy, they move or vibrate less. This means that there is less space between the particles. Particles then take up less space because there's less space between them, and the object gets smaller. So it means that it contracts. For question 7, what is a bimetallic strip made of? It's basically referencing the bimetallic strip. Bimetal and bimetallic, they mean the same thing. They are made up of 2 different materials which expand at different rates, and the most common example of that is steel and copper, but it can be steel and brass or iron and brass. Question 8, do gases expand? They do, and they expand even more than liquids and solids. And the last question then, why are shelves in an oven fitted loosely? It is because the metal expands when heated and contracts when cooled. So when the oven gets hot, the metal shelves expand, and when the oven cools, they contract. So fitting them loosely gives the metal room to expand and contract. This is now the end of the lesson. Thank you.